All right. Cool. So I saw Sean just dropped a note into like who to stay up for. There's also a couple other people that post. I'll just try to, you know what, over the next week or two, I'll just put together a list of people that I think are worth following, and people can start to check out that. All right. So thanks for intros. I'm just going to do a quick intro into who I am. I know many of you have seen my work already. I actually have updated these slides for people who've seen this like for the third or fourth time. So I do have some new stuff to show you. But, you know, I think like many of you, like I'm in a similar place. Like I do product design during the day. I dabble in this stuff a lot. I've been invested in it for a couple years now. And really what I want to make this class, like I want to make it accessible to people who don't spend all their day in Discord or don't spend all their day like going through like AI artists on Twitter. So I think, you know, for me, it's really important that, you know, maybe to what Rox mentioned, like other people who are not completely invested in the space get to utilize the tools, maybe understand the tools and honestly find their own path for them. So that's similarly how it happened for me. So Rox also mentioned SFPC. I'm also sort of a graduate of that program. I took a similar immersive class to what Rox did, learned from these folks. You know, it's kind of funny to look at this list now because I would have said 2 years ago, like, these are still the people to know in the ML world. And I'd say today, like, these are still some fairly important people, but like definitely the world has changed a lot in the past couple of years. But it's kind of funny because when I met Cristobal Valenzuela, he was a grad student ICP. And about 6 months after I met him, he created the company called Runway. And it's now one of the big tools. You know, so a lot of these people have sort of bounced in and out of the field or doing other work. But I learned a lot through them and sort of kept up with it that way. And for me, it was like, you know, just like for many of you, my first class, I was like, this is amazing. This is so great. But I was so overwhelmed. I was like, I don't know how to get back into this. So I took like 3 months off and then, you know, tried to get back into it. And when I tried to get back into it, there weren't nearly as many resources as there are today. Like today, I was really like, I should look at some stable diffusion videos on YouTube to make sure I'm not talking out my ass. And I was like, you know, Googled, you know, stable diffusion on YouTube. And I was like, oh my God, there's like 1,000 videos on here. Like this is such a different space than it was when I started. When I started, I think the only videos I had available to me were genes. That was it. And I was sort of like, okay, this is really hard. Like getting this stuff up and running. This is before Collab existed. This is before other tools existed. I was like, this is so hard. And I really started these classes and my YouTube channel as a way to sort of like be like, here's what I've learned. Please someone go take this and use it, because it was really painful for me. You know, this was some of my first earliest work. Like this thing on the left is some sort of GAN. I don't even know what this GAN would have been at the time. On the right is like style transfer, which like no one uses today.
Derek, are you doing a presentation?
I'm not sharing it, am I? Nope,
No.
I'm not sharing it. Thank you. Awesome. Perfect. Thank you for that. Okay, so yeah, so these are the people, if you want to screenshot this real quick to look up their names. These are the people in the SFPC group. Thanks for that, Rox. This is some of the work I was talking about. So on the left is like a really old GAN. This might have even been just called GAN at the time. On the right is style transfer, which again, most people probably don't use today. Although I actually think we're kind of getting back to style transfer in the way that a lot of these new text to image tools work. I think we'll look at some stuff similar to that, but this is kind of a funny, it's not a very good version at that point. You know, since then I've been doing a lot more work, sort of editorial work for magazines, newspapers. So this piece I did for the New York Times, actually, Francisco, I don't know if you've seen this article, but it's actually an article, this is probably 2 years old now, but it's all about some of the EEG readers or other tools to read your mind and then generate images from it. So I was asked to do a bunch of pieces for that, which was pretty cool. On the right here is another style transfer piece that was a little bit newer. I thought I was getting a little bit better at that. And then, you know, for me, like the past couple of years, as maybe said, like I did a lot with StyleGAN, but I have played here and there with text to image as a part of this work. So, you know, this is probably from like, actually, Sean, I think this is from the class that you and I were in together. So we were generating images. This uses a tool called Aphantasia or Illustrip. So this would have been, you know, first 6 months of open source text to image, during videos and other things. And we'll probably look at more examples of this as we go through next week's class, which is sort of like, there are so many text to image models. Which one do I pick? Do I just always pick the latest and greatest, or do I go and actually find out what the nuances of these tools are? And I think I still sometimes look at Aphantasia or Illustrip because it's got a look and feel that like none of these other tools had or have. So it's kind of an interesting one to play with. Last month, a project that I worked on all of the first half of the year just released. It's for a font foundry called Commercial Type. They released a whole magazine that was around food in New York, and they asked me to illustrate all of the entire magazines, and there's like 7 or 8 articles. So I did a couple pieces that were text to image because that was kind of the hot thing at the moment. I was like, I'll do a little bit of it, but I don't want to go too far into it. So it's a mix of sort of my StyleGAN work, other projects I've done in ML, non-ML work, and then this was kind of one of my favorite pieces out of it. This is a portrait of Helen Rosner. I think that's her name, Helen Rosner. She's a very well-known food critic. And this was a text image piece that really is, I think it's something like 16 different text images that were then sort of recollaged back together. And this is something you'll also learn about me if you've never taken my classes. Like, I really encourage us to take our outputs from these machine learning models and do our next art piece with them, right? It's not just like text image is it and I'm done and I like never need to play with it again. It's like the output from the model is all I care about. I think for most of us, it's just a starting point. It's a place to get us to one step. Then we take it and we bring it into our practice or do other things with it. And I think many of you are already talking about that. And it's like, you know, I'm an artist doing this, but I want to play it and dabble around machine learning as either concept generation or starting points, and I want to take it and go from there. And that's how I sort of approach these things. So the other thing I'll mention is like, I try to work with these tools conceptually. So this image is also, I'm going to butcher the artist name, Arcembello. There's an Italian artist who, if you Google his name, if you do like food portraits, he was like a 16th century Italian artist who made portraits of like kings and monarchs using food, you know, sort of poking fun at them. So this is sort of a reference to that because Helen's work is often considered very lowbrow food critics. She talk about Chinese food restaurants or other things. So the other thing is I'm trying to do with these tools is like, not just reference like it's machine learning, but also try to think about them as conceptual tools. And that's also this next piece, which I'm just put out like a couple of days ago. I'm currently doing a project right now this month where I'm doing a new video every day around a bunch of scream scenes from horror films. And this particular piece was a stable diffusion piece where I took a bunch of videos, the little video clips from like famous horror films of the 70s, 80s, and 90s. And this takes Edvard Munch's Scream and sort of combines the two ideas together, right? So it's kind of a tongue-in-cheek way of thinking about scream scenes. I'm gonna mute this as well. But you're welcome to watch it and listen to the screaming. I just feel like my partner has heard screams endlessly for the past 2 months from my studio down here. So, but I think, I forget, maybe someone was saying this, but you know, one of the interesting things about these tools is they're not really great for animation just yet, right? Like there's no like fluidity here. There's a little bit more of like a stop motion feel to it, which I think is interesting, but it's kind of a challenge of these tools if you're used to like, I want fluid 3D motion, that sort of thing. So that's just a little bit of sort of what I've been working on. Again, it sort of does do some stuff with some of these text image models, but it tries to do things in a little different way, like that sort of thing. But I think like, especially when we get into ethics, I'll talk a little bit how I approach it. But everyone can kind of, I find everyone has their own limit of what works and what doesn't for them, but I'll sort of talk about how I approach it and what I think is acceptable and what isn't. But yeah, so we'll sort of talk through some of that as well. Okay, so schedule for this class, as I mentioned, is a little loose, but I think this structurally is kind of a nice way for us to think about it. So obviously today we're just going to look at Colab. We're going to finish up a little bit of what text to image is as a theoretical model. Next week, we're just going to dig into a bunch of models. We're just going to look at a bunch of different things, different interfaces, try to get a sense of like, what kind of look and feel can I get with different tools? Week 3, we're going to talk about prompting. Prompting is like the most important thing in text to image. So we'll definitely dig in deep into that. We'll look at some tools to help us generate better prompts. We'll look at other ways to generate prompts, that sort of thing. Week 4, we'll look at image and video. So, you know, part of what I want everyone to gain out of this class is a little bit more control. I think everyone sort of plays the text to image for 5 to 10 minutes to an hour and is like, that was cool, but like now I want to do a very specific thing. How do I do that? So we'll try to look at how to gain a little bit of control for these tools. Week 5, we'll look at what's called inversion. And we'll also look at maybe training a model. I've done a little bit of training with these tools. And again, this is a case where I probably wouldn't ask all of us to train our own model, because building a data set for this is really painful, because you need text and images. It's kind of a mess. But we might try to do like a class model, and I can train it for us and play with it. And then weeks 6 and 7 are really like, I want to help all of you think about projects that you want to work on. So either you try to finish it in those 2 weeks, or we can just set up some time for us to chat and sort of work through one-on-one. But also I tend to find people have like half the class has questions about things like upsampling, or, other questions around things. And I'll sort of do little lectures to sort of talk about these ideas together. So this also might be where we like look at stuff like how to set up your own server, how to run your own server if you don't want to use Colab, like those sort of things. So as I mentioned, materials for this class are, you will get these slides every week. So I'll like basically put them in the chat the day of, because I basically am making them up until class starts. And then I'll share them again over Slack. Recordings you'll get basically every day the next day. So, please keep me honest. And if you're like really itching for that recording, is it up yet? Like, I'll make sure it's up. And I'll also drop that in the Slack. So our Slack channel I mentioned, like, please join it. For this class, it's kind of our way to talk and chat. You probably won't get any more emails from me. You'll just be like, you'll get notes dropped in our Slack channel. So I find it's a little bit easier. Again, if you find cool things and you want to share them, please share them in the Slack channel. Like, there's no like, only Derek can make announcements in the Slack channel. Like, don't use that here. I think we all know that etiquette at this point, but like, please feel free to share links, share ideas, share cool things you saw. If you're like, how the hell did someone make this? They can try to debug or break that down. So please feel free to use that. You're always welcome to email me or DM me privately if you have questions. But in general, I would prefer that people post those in our Slack channel, in part because if you have that question, probably someone else does too. And it's a little bit easier if I can just answer it for everyone rather than like, one-on-one sort of trying to answer questions. So unless it's like private or personal or something else, I'd say let's start by posting in Slack and see how that goes. If there's 50 questions every day in Slack, that's kind of a good problem for me to solve. In general, I find that, usually there's a couple questions a week from everybody. Yeah, that's sort of my default way of working through these things. So my objectives for y'all through this class is, one is just giving you sort of a survey of sort of what tools and models are out there, because there's a lot, like, as you mentioned, like everything's exploded. I'm going to try to tell you what I've seen. I think like people sort of gravitate toward, what I think works well. Also just knowing that like a lot of us are not super code people. I think finding the tools, there are a lot of nice tools these days that don't really require us using code or Colab. So I'll definitely try to like err more toward those sides. But I know some of us are interested in code and that sort of thing. So I'll also share links to other tools as well. Because yeah, it's a lot. And I think I'll just sort of break down sort of what I found works and what doesn't for some of these tools. As I mentioned, I think a key thing for me that I find people really struggle with in this area is, how do I gain better control over these tools? It's really easy to just like generate one image and like be like, that's awesome. And then, for those of you that have, done editorial design or whatever before, it's like, you share an image with an art director and they're like, that's cool, but can you do this, or can you move this thing here? And you're like, oh, holy shit, that's gonna be really hard. So we're gonna talk about how to actually achieve a little bit more control in these tools. We will look at creating custom data sets. It's a big task because you need a lot of images. If you've been in my style game classes, I'm like, 2,000 images would be nice. And everyone's like, can I do 500? And these models, you actually do need like 5,000 images with captions. So it is very hard. So what I might do is like set up little dummy data sets for us, a class, and we can maybe sort of train as a group, or like sort of group bulk caption images and sort of try to create tests that way. And the other thing I want to talk about is this stuff is bringing up a lot of ethical considerations, right? As Emily mentioned, like 3 or 4 years ago, it's about making your own data set. Now it's about using these models where you don't even know what data set they're using. So what does that mean? And we've seen a big backlash from artists who are saying like, wait, you're using my data in these models? Like, don't I have any say in this? So I think we can talk through we can look at some tools that have started to uncover, what images are in these data sets. What does that mean for the models themselves? But also try to start to think about like how we can ethically work with these tools. And for some of you, maybe like after learning all this, like I can't, it just doesn't feel right. And I'll try to give you sort of my guardrails for what I think works. But at the end of the day, I think it's up to everyone to sort of have their own approach. And as long as you think can like logically defend it, I think it's, valuable. And I think this tool is really amazing. And I don't want to see us throw out the baby with the bathwater, right? Like I think there's really a lot of value in using these tools. But I also think if we just blow through and like ignore any artist's sort of ethical considerations or copyright considerations, that we're just doing a disservice to these tools. So we'll talk about that for sure as we go through this class. So homework, there's homework every week. It's like I try to give you like sort of a loose assignment that I think, if you need guidance, it will help you sort of get there. I recognize many of us have full-time jobs or families or other things. So I'm always flexible with the homework. There's no grades in this class. Like I want you to learn. I think a good way to learn is by doing examples and playing with stuff. But at the same time, I know some weeks you're going to have lots of time and other weeks you're going to have no time. So there's no, pressure from my side. I always recommend, I think Adam mentioned this, but like pick a project or like, maybe 3 or 4 weeks in, you're like, oh, I really like this as a concept. How do I play with that more? That's enough. Like that's going to give you enough of a space to really work and learn. Other people do try to do everything, throughout the entire class. And like, I'm certainly appreciative of those folks. They have a lot of questions, but I know it can be hard for the people. So yeah, as I mentioned, like there will be like final projects, like we'll sort of figure out how we want to do that. If we want to do like last week, we'll share and show and tell, or if we want to do recordings of our projects. Everyone will have their own amount of time available to them and have their own interest level. So I'll leave it up to you to sort of figure out what the scope of your project is. Maybe it's just more of like hey, I did these 5 things and here's the thing I learned, or here's the thing I would like to do more of. That's fine with me. Some of you may have all ideas already and you're like, I really want to do this thing and figure out how to make that happen. And I'm happy to sort of help you work through that. We didn't even talk about this, but I will set up some one-on-one times for us as well. So usually what I do is I set up like an hour every week where I'll show up on Zoom. And if anyone has questions, they can show up and ask questions and go through stuff together. I'll try to find a time that's pretty much around this time, like just on a different day. If that doesn't work for folks like Tobias in Germany, if you want to sleep at other days of the week, that's fine. Just DM me. We can find time to chat. I'm always happy to like find a time, like 30 minutes or whatever to work through things. So make sure we do that as well. So I'll probably set up some times and maybe just like announce them in our Slack channel. And we'll start probably not this week, we'll probably start the week after because you'll actually have stuff to ask me after that. Okay, you know what? We're at 8:30, so let's skip the demo. I think it'll be fine. So when we take a 10-minute break, so we'll come up at let's come back at 45 after. So we'll come back at 45 after and we'll dig into some of this material and talk a little bit about what text to image models are. All right, see everyone soon. All right, so also I dropped in our chat. There's a really great person to follow if you're interested in lots of AI material. His name is AK. He just posts a ton of papers from Archive, which is a place where lots of papers get stored. Lots of cool ideas and like I think lots of like good machine learning people follow him because he's always unearthing like really interesting, unique sort of papers that are worth reading. One thing Lee and I talked about, like when we were still during class ideas together, is we talked about like having a paper reading class where we just read papers and learn how to read papers because it's kind of a daunting task. I don't know, maybe we'll bring that back for next year. But yeah, it's there's some just really cool concepts, and you can always just go to the pages. Like now people have a paper, they have a GitHub, and they have a GitHub page that like shows examples. Sometimes you can just go to the link for the GitHub page and see what cool ideas they have and see if it's worth investing in. But yeah, I'll try to put together a list of other people that I think are worth giving a follow. Yeah, it would probably be a couple weeks of a workshop. It would be pretty short because I think I would get burnt out if I had to read a paper a week. That'd be a lot. That'd be like actually like grad school. I don't want to do that. So that's really is that. So not for me. I'm too old for grad school at this point. Cool. So let's go back and I'm going to talk a little bit about just sort of how text image works. Just give you some high level theory. And again, if you don't understand all of it just yet, that's fine. We're going to look at it pretty much every week because every week we're going to come back to and be like, okay, what are steps? Okay, how does denoising work? That sort of thing. But I just want to quickly talk about a little bit how it works. All right, so those of you who have been in my class for a while, I promise I updated my slides here, but you do have to look at Terminator for one more class. So I kind of think it's funny, like, feel like the AI world got off of the whole supercomputer end of the world thing, and then text to image got good enough that now people are back to about like computers are going to take over the world, like this whole thing is going to like destroy us or whatever. And so again, when you hear is also really back because people are also talking about these other things. Anyway, long story short, you're going to hear people talk about AGI, right? And what AGI is general AI. And it's this idea of robots, supercomputers, these other things are going to take over the world. And doesn't text to image prove that the machines are getting so smart they can make art that they're going to like very quickly also like take over our world? And I'm far less bullish on that idea. I think even text image is a great example of what like we try to focus on in these classes, which is narrow AI. And that's code or like algorithms or other things. It does one thing, and it does one thing sometimes really well, but oftentimes okay. Not really well, but like it does an okay job of it. And I think, you know, many of you know my favorite example of narrow AI or code that does one thing is horse to zebra. So this is now like 5 years old now. And horse to zebras was really just a way to take a image of a horse and turn it into a zebra. And 5 years ago, that was this novel concept, like, holy shit, like this actually works. And what's funny is I actually think horse to zebra is actually a good analogy for what text to image is going to do. So keep horse to zebra in your mind as we go sort of through the text to image world or journey. And we'll come back to maybe that exact sort of, maybe not exact, but that analogy. Because I think like text to image operates fairly closely to how horse to zebra does. And we'll talk throughout this whole class for the next 5 or 6 weeks about fine tuning our text prompts or fine tuning our settings to actually get to a place where it does what we expect it to do. Because I don't know how many of you have played with sort of like your 10 minutes of DALL-E where you don't know anything what you're doing. You generate 1 or 2 good images and you generate a bunch of crap. And that's kind of still true with all these models. You know, a lot of what you see on the internet where someone says, oh, I made this with Stable Diffusion. It's like, they probably made 100 images and they shared the best one they could with you. And that's kind of one of the tricks with a lot of these tools is like, people show these great examples and you're like, oh, I want to do that too. Like, let me go do that. And then you generate your first couple samples and you're like, this isn't good at all. Like, what happened here? And then you learn like, oh, they share a text prompt and it's like 60 words and there's weights and there's other stuff in it. You're like, what the hell is this? So we'll go through that in this class. Like, we'll talk about sort of like what they're doing, how they're doing it, that sort of thing. But I think it's important to recognize that like a lot of people use text to image as like this cudgel for like, this is the future of the world, like computers ready to take over. And it's like, they really aren't. Once you dig into these tools, you're like, these programs need a lot of handholding and they need a lot of sort of like human computer interface. So there's no way that we're like ready for Terminator, you know, this year or next. It's not going to happen. 20 years from now, maybe, I don't know, but I don't really see it happening. Humans will destroy humans before we get to robots destroying humans, I think. So a really brief little history into text to image. For many of you who took my classes 2 or 3 years ago, you know my favorite demo was using this tool called Attention GAN. And 2 or 3 years ago, this was state of the art. I would ask us all to generate a text prompt, and then I'd use Attention GAN and we generate images, and they all look like crap. And this is an example of Attention GAN where it was generating birds using text. And this looks pretty good. This is absolutely 100% cherry picked. They found the best example ever made using Attention GAN because I've never been able to reproduce these results. And this is kind of one of the challenges with a lot of these tools is like a paper comes out, they say like, oh, look how good this is. And they found the one sample that proves their point, and that's what they highlight. And again, as we go through text to image, we find kind of a lot of similarities there as well. But in 2017, this was like the example of these models working. And honestly, I was really excited. I thought like we would see more of this. I thought we would see more people trying these sort of models. And it didn't really happen for like 4 years. Like this was the best version that you would find of text to image. And then in very early 2021, a company called OpenAI came out with this model called DALL-E. And with DALL-E, they said, we've gone back and we've redone all of text to image. And we've generated this thing where now you can generate an armchair in the shape of an avocado. And they, on their website, they had a bunch of images and tools, and people were like, this is awesome. When do we get it? And they said, oh, never. We're never giving you this model. And I don't think they actually ever did. I don't think DALL-E was ever actually released. I think they might have had an interface for it for a little while, but they didn't release the actual image generation model. And when we get into a little bit deeper into how text to image works, we'll talk about how there's actually really two different models. There's the image generator, and then there is CLIP, which is the model most people use that actually does the guidance. We'll talk about what that means in a minute. But they said, we're not giving away the image generator because it's too powerful. We will, however, give you the CLIP model. And people are just sort of like, that sucks. Like, what the hell? And 2 days later, Ryan Murdoch, who's a friend of mine, put up this on Twitter. So he used the CLIP model, which is what they did provide, his own image generator. And he said, I was able to use CLIP to visualize this prompt called a photo of a white analog clock. And I think we'll kind of sort of see this, like, this is now like the prototype of what's going to happen over and over again for the next 2 or 3 years. Within days of these models being released, like, people are able to sort of cobble together their own versions of them. And I think this was a really big moment because people saw this and like, they were like, oh, I want to do this too. And a bunch of people like started working with Ryan to sort of like figure out how he was doing this. People found out weird little hacks to like optimize this code. And you'll see like this image is not that good. Like there's lots of problems with it. And over the years, we've sort of like figured out, well, how do we remove text? Or how do we do these other things? That, you know, today, so this was Ryan's image from early 2021. This is an image from 2 or 3 weeks ago by Simon Willison, right when Stable Diffusion was released. So we've gone from this to this in about 2 years. Probably even less, because I think the first version of DALL-E 2, which came out, I don't know, maybe a couple months ago, maybe even 6 months ago now. God, time really does fly. Also got to sort of this level of skill and like quality and realism, which again, we'll talk about this more as we get into these models. Like realism tends to be how people judge these things. I don't really like that as a concept because I think like realism is just one part of art. But again, a lot of people tend to use realism as a way for, here's how computers are like, you know, going to take over the world. So I think there's been so much that has happened. And I think many of you have mentioned this, like, I want to get in text to image, but it all moves way too fast. Or like there was a new model every day, and there kind of is a new model every day or a new tool every day. So what we're going to talk about is just sort of like, let's break some of these ideas down into basics, and then we'll sort of like build ourselves up into that world. So as I mentioned, like text to image really blew up because of OpenAI's CLIP model. And the whole idea for CLIP, for those of you who are not familiar, is that it compares images and captions, and it provides a score on how likely the two match. So with CLIP is a machine learning model. You feed CLIP an image and you feed it a caption, and it kind of gives you a score. It says, here's how closely these two ideas match. So part of this is we also need to get into how corporations work, or like how particular corporations have their own theories. OpenAI as a company believes that the best way to improve machine learning models is by scaling data. So before, attention GAN, I think, was probably trained on some like 5,000 images of birds and captions of birds. And OpenAI came along a couple of years later and said, like, 5,000 images, that's not nearly enough. Let's train it on 5 million images or 5 billion images. We still don't know actually the data set that OpenAI trained on. They said, let's just scale the hell out of this. Like, that's sort of OpenAI's whole approach to everything, is like, let's take a tool that someone else wrote code for, or someone else wrote a paper on. Let's take that and let's send 100x the amount of data to it. And this is where we get into some ethical issues. This is where we get into some other issues that we need to talk about. But OpenAI just basically went on the website, on the internet, and scraped as much data as they could. They said, where can we go grab images that have captions with them? Or where can we go grab images that have alt tags on them? And we'll also find out that though, because they scrape data from captions or alt tags, there's a specific way that like the model's learned. So this is sort of a concept is going to become a big issue for all the work we do, because clip at the end of the day is actually the model that really guides most of our tools. So again, really simple idea of how clip works. This is not exactly how it works, but it's close enough for our intents and purposes. Is you feed an image to a model and you say, here is the text that goes with it, and it gives you a score. It says, oh, I kind of see a horse-like image here, but it's not really a horse. So it's going to give you a score. And let's say it gives you a C minus or whatever. The idea behind our models as we go forward is that we're now going to attach a generator, an image creator model to that, and we're going to use the two together. So for a while, you were kind of seeing models being called clip plus something, clip plus VQGAN, clip plus something else. And the idea was always that like, we're going to use clip and then we're going to attach another image generator to it. For a long time, that was a GAN because GANs were the most important or the best generating models at the time. Since then, and maybe the past year or so, people have sort of dropped the clip plus idea, and it's just like assumed you're using clip under the hood or using some clip-like model, because there were now people are making lots of their own versions of clip. But the idea is still important. It's like when we talk about using these models, whether you're using stable diffusion or disco diffusion or VQGAN or some of these other models, that it's always some text image classifier, text image scorer, plus this other model. And we'll cover this a lot more next week when we actually look at some of the different models available to us. But it's often some image generator plus this guidance, we call a guidance model. When I wrote this slide maybe a couple months ago, we didn't have stable diffusion yet, but these are some of the open source or like some of the ideas of what models are available. So that first version I showed you with Ryan Murdoch was what was called Deep Days. It was that model plus a model called Siren. Other ones that were probably pretty popular for a while were Hypertron, which was one particular version of someone's clip plus VQGAN. Clip plus VQGAN, I feel like for a good couple months was like the contender or the version. Then we moved to the diffusion models. And I'll talk a little bit more about diffusion models in a minute. But the idea here is that the key part is you can always attach some image generator or 3D model generator or other things to clip. But this text scoring, this image and text pair scoring idea is always underlying these tools. So even stable diffusion, which is sort of like dropped the whole idea that clip is inside of it, is still using a text guidance method inside of its model. And we'll talk a little bit about how that whole model works together as a pair in just a minute. But it's important to remember that like next week, we're going to look through some of these examples and see that despite them all using clip, they all have different visual outputs because the visual output is defined by the image generator. The visual output is not defined by clip. Well, in some subtle ways it is, but most of the image output is generated by the actual image generator. So everyone's probably at this point heard of stable diffusion. And before that, we had a thing called disco diffusion. And you might be wondering, like, what's up with diffusion? Like, is it just like a cool sounding name? Diffusion models have a very specific use case or a very specific process to them. And this is where we're going to come back to horse versus zebra. So when you hear something called diffusion, diffusion is a type of model that does what I would refer to as image to image, meaning it takes an image and it converts it to another image. And the specific like idea behind diffusion is actually that it takes an image and it converts it to noise. And then learning that noise process, it's able to learn the reverse. And we'll go through this a little bit detail in just a minute. But I imagine that I take 5 million images and I train my model to slowly add noise to that image, right? So I take 5,000 photos of cats and the model learns how adding noise affects the image. There's a very common thing you see in machine learning, which is like, if you learn to train a model in one direction, it also learns how to train in the opposite direction, or it also learns in the opposite direction. So the idea here is if the model learns to add noise to an image, it can also learn to take noise away from an image. And this is actually the diffusion process that matters the most to us, because what we want to do is we want to conceptually give you a text prompt and then say, generate it from nothing, right? Most of the examples you see online are like, You just put in text and it generates an image from you. So what it's actually doing behind the scenes is the reverse here. It's taking the text prompt and it's generating random noise. Not always random, sometimes it's like purposeful noise, but it generates noise, and then the model actually inverts the process and removes noise as we go through the process. So this is basically, I mean, this wouldn't really work, but for those of you that have used like Pix2Pix or some other model like that, like you could build the same concept using Pix2Pix. There's some subtleties in why it wouldn't work, and that's sort of like why diffusion models sort of like are what they are. But this process is essentially, this is all that diffusion is. So in most cases, when we're going to use a tool, well, I should say in some cases, it will actually show us the steps that generates an image. And that very first step will be noise. And that's because it's generating this noise and then it's trying to learn from the noise or trying to generate an image from it as we go through it. So this is the generative model, right? This is the model where we are generating images from noise into images, but we're also using clip to actually guide that image as it generates. And that's kind of the important thing here is diffusion models actually don't work that well by themselves. So style GAN or GANs actually work pretty well as by themselves without needing some sort of guidance system. Diffusion models actually do need that guidance system, but because of this denoising process, they can generate better images than GANs could, because GANs are really built around a singular topic, right? Like the best GANs are face GANs or all of the same data set that's been aligned. It's really hard to take a model that has been trained on a certain domain and then tell it to look at something else. Whereas diffusion models, because they don't have any innate like data that they're built on, because they're really purely noise-based, you can generate a lot of different ideas from that noise. And that's kind of the key for why you're seeing a lot of these tools move to diffusion, because it generates really high quality images because of that noising process, or the denoising process is actually what it is. So, you know, this is kind of why we're seeing people move to this, but there's a challenge here. And we'll definitely cover this when we get to video. The problem here is that video becomes a really hard, it's hard to do stable video using this process because you've got all that noise, right? You always have to add noise into your images to generate your next image. And noise, as we know, is pretty chaotic and pretty random. So that's part of the problem with some of these tools. I won't be surprised if they solve it in the next 6 months to a year, because it's guaranteed like a very hot area of if you could export video using these tools, it'd be game over for a lot of people. I don't want to sound game over, seems like too robot, like too Terminator again, but it's like it would be a big business for a lot of people if you could generate random smooth video from these tools. Let's just say it as that. So again, the important thing to remember here is that we have two models. We have our generator model, which for all intents and purposes today is diffusion. And then we have a clip model, and that's our text scoring guidance model. So the process for this is we want to generate a text prompt. So let's also like, you know, make up a text prompt, and we'll say a beautiful painting of a dog riding a dolphin. Our very first step with these tools is to generate a noisy image. And every tool has their own version of noise. This happens to use aphantasia, which is fine because I like the noise it generates, but it generates random noise essentially. We then use clip to score that. So in this case, this looks nothing like a beautiful painting of a dog riding a dolphin. So the model kind of learns from that and says, oh, okay, I need to steer my model a little bit, which I do. So this is what we call a step. Steps are going to become really important when we look at stuff starting next week. Steps are like, actually for stable diffusion, they're a little bit less of an issue. But steps for pre-stable diffusion were like a big deal, because dialing in the right amount of steps is really important. Steps also are how long the model takes to generate an image. So if a step takes a second and you do 500 steps, that's going to be 500 seconds to generate your image. One of the things that stable diffusion is good for today is that it's much faster, it requires less steps. It's very fast. Whereas other tools pre-stable diffusion tended to take a long time. Aphantasia, I know like when I generate videos, it takes like overnight. It takes 24 hours to generate a video for those. Stable diffusion is a lot faster with its own caveats. But anyway, we take this step, we get our score, and now we need to update our image, right? So we update our image, and now we've got a like sort of abstract looking dog with an abstract looking dolphin. And now we have a clip score. I'm making up these numbers because clip doesn't actually give you a score like this, but let's just say, hey, 40%, you're like you're failing, but it's better than it was before. Do it over and over and over again until you either reach your maximum steps and ideally your score gets better, right? Like that's sort of the goal here. Now, this is where, for those of you that have done this before in my class, like this takes a lot of time to dial in the right amount of steps. Should it be 200, should it be 500, should it be 1,000. Again, pre-stable diffusion, we were like, some people were doing like 3,000 steps per model or per image. That's a long time to generate those images. We'll talk about this more next week when we get into stable diffusion. Stable diffusion, they usually say the max is like 50 steps. It's a lot less steps. But for other models, it is a little bit of like hand holding and a lot of like dialing in these number of steps. But another interesting kind of thing here you'll see is that, well, I've got my like pseudo-ish dog looking mess of a thing. And then I've got kind of a dolphin looking thing. But I've also got flowers. I've got landscapes. I guess there's even a dog or two like showing up here. So what's happening here, right? So the question is, my prompt was a beautiful painting of a dog riding a dolphin. This is where we need to start like inverting and like thinking about how the model was trained. So we'll talk about this more maybe 3 weeks from now or 2 weeks from now when we talk about text prompts. One of the challenges is that when we say something like a beautiful painting, that means a lot to these machine learning models, right? It's seen a lot of images that have been said as beautiful paintings, right? And like a lot of them are probably landscape paintings from like museums. So what's probably happening here is I said a beautiful painting. It's like, oh, that means you need like flowers, like Monet, right? So we're getting like Monet-like flowers popping up in here. This will become a big topic when we get into text prompts, because how do I control that? I don't want flowers in here. So like, I just want a dog riding a dolphin and it needs to be beautiful, but I don't want flowers. How do we control that, right? This is where we get into like control and these other things. It takes a lot of fine tuning to really get into like what we want to do here. So this is now the hot term for like what we do with text to image models, which is prompt engineering. So CLIP, by its nature and the way it was trained and the data set it was trained on, there's a lot of specific keywords that those models latch onto. So one thing that we know sort of happens is if you want something to be aesthetically beautiful, you literally ask for like a beautiful image of X. That works because people have captioned their images and say this is a beautiful image. And it's a painting from the 17th century, right? Like all these biases that people put into captions have now entered into our lexicon for these models. And that's just kind of one of the challenges of these things is like, you kind of have to think like a data set or think like a captioner of images to then reverse engineer what you want your image to look like. And this has become a thing called prompt engineering. And there's jokes about like this being the future of our jobs, because all our jobs are to like figure out what the computer thinks so we can make it do what we want it to do. But we'll talk about this a lot more over the next couple weeks, because this is really a key to think about how we can control our images in better ways. I also just honestly think these models might be dumb, right? Like this is the other place where like people are saying like, oh, look how smart these models are. It's like, no, they're not smart. They just learn, they learned like a, like a child, like learning rote to answer test questions. It's not interpretation. It's just literally like, I saw a bunch of museum paintings by Monet that said they were beautiful. So that's what a beautiful painting is, right? There's no intelligence in that. It's just purely like, I saw a bunch of things caption this and I just like, I'm spitting it back out at you. So really funny things have been happening throughout the space. Like, oh, if you want more detail in your images, you literally say like, I can't believe the detail in the needlework, right? Again, because Clip went and scraped a bunch of images, from probably forums where people post paintings or drawings or whatever, people would respond like, oh, I can't believe the detail in that image. And the model would pick that up and say, cool, can't believe the detail in the image. Like, let's add detail. It's kind of silly, but like, that's actually what people have found works well. So we'll talk a lot about how prompt engineering, even though you might want to be abstract with your concepts, when you're prompting, you actually need very specific literal language. Here's a good example. Asking someone for a fork in the road, or asking these models for a fork in the road, we all know what a fork in the road is. DALL-E doesn't. DALL-E sees the word fork and it sees the word road and it says, I got you. So if we really wanted a fork in the road, we would need to tell these models something like, can you give me a path in a garden with two split paths that merge or something like that, right? Like, so even when we want to be conceptual, we have to be literal with these models. And this is another thing I think I see people do on Twitter a lot, which is like they post prompts that look like prompts, but they're really not. It's more like their conceptual prompts, but not probably what they gave the model. And like that can confuse people because you're like, oh, that was all you prompted with. That's really cool. And you're kind of like, oh, but they didn't actually prompt with that. They prompted with something else, and that's their like conceptual quote. So we'll talk a lot more about text prompts. We'll look at some tools that help us generate better prompts. Look at some other ways to sort of learn about prompting. But just know this is a very key part of our experience we do generative modeling. So these are a little out of date now because these were all pre-Stable Diffusion. And I believe, I don't know if Stable Diffusion even uses Clip. I think they generate their own Clip, their own text image guidance tool. But there are a lot of people who have gone through over the past year or so and literally documented all the different tricks and hacks and other things for these tools. So I'm not going to spend a lot of time. I'm not going to open these because we have to jump to Colab. But if you're interested, there are some tools here. We'll come back to some of these, I think, over the next couple weeks. But people have like really dug in and like documented the hell out of what text prompts do or what other word hacks there are available. So some interesting tools. We'll look at some of them over the next couple weeks. The other thing people have figured out is like how to hack in. Well, I don't want to start with noise. I want to start with an image that I have, right? I want to start with my picture, my face, and I want to add something to my face. People have sort of figured out how to do that. There's all these things around like weighting different words. So if you're like, hey, I want more dog than dolphin, but I want, some of both, there's ways to do weighting and other things. So we'll look at all these tools probably starting next week. But just know that like there's lots of little settings. And this is really where it gets into like, lots of people show like, oh, look at this amazing image I made. And it's like, it took them 24 hours to set up all the right settings for it. And they showed you it and you're like, oh, I did it in 5 minutes. And it's like, no, that took you a long ass time to figure out. And that's, again, I think there's the reality of these tools and there's the like hype of these tools. People say, oh, I typed in this thing in a DALL-E and got a perfect image out of it the first time. And it's like, maybe you got lucky, but most of us have to type in something 100 times and get a good image out of it. And I think as we go through this class, we'll see like that's definitely true. Like you got to spend an hour just generating your prompts or like tweaking your prompt until you get the right image, that sort of thing. So in this class, we are going to focus on Stable Diffusion. The reason we're going to focus on Stable Diffusion, it's the newest thing, but also like it is open source. There's other image generating tools like ImageGen or DALL-E 2 that we just don't have access to the code or like the models themselves. And usually those tools are like either like you have to apply for API licenses, or you have to pay them or other things. So with Stable Diffusion, it's pretty easy for us to use. And because it's open source, there's like this huge amount of tooling built around it. People are customizing and making their own models. People are generating GUIs we can then play with. Like there's just a ton of opportunity here. So we'll probably look at those tools because it's just the newest thing and it's fairly accessible. I would say it's also the best realism. And again, I feel icky saying that, but I think like realism is one way to approach these models and think about how they work. Next week, we'll look at a bunch of tools and you can sort of decide like, I don't really like Stable Diffusion. It kind of looks very anime-like or very like 3D poly kind of look. I like Aphantasia because I like that like pixely noise. Or maybe I like VQGAN because it's just like more abstract, whatever it is. So we'll look at some examples, but right now Stable Diffusion is the hot thing. I think it's helpful for us to talk about it. I do think there are lots of modifications and new tools out. To many other people's point, probably too many. There's probably a new thing literally daily at this point. I'll try to focus on some ones that I know are well supported, because the other challenge of some of this stuff is like, again, people get burnt out. They build a cool version of a thing and they never support it or never update it. I'll show us some tools that are generally being well supported and well updated. So at least for the next 3 to 6 months, we've got a tool we know will work. Because that's kind of the challenge of the space too, is stuff goes out of compliance or just breaks or other things, and then no one fixes it. So we'll look at some stuff that I know will work well or like work well for us in the future. Here's a short list of stuff we're going to look at. If you know what these terms are, excited to work on them, like we'll definitely at least cover some of them. We're definitely going to look very quickly at Auto 1111, which is a web GUI. Again, I think it's nice because it's a really nice GUI that'll allow us to play with lots of different tools. So for those of you who Colab is scary or Colab is too much code interface, I think we'll really like using Web GUI because it'll give us access to all these tools without having to like dig into code and writing lines of code and that sort of thing. We'll kind of look at if we like all want to look at DALL-E 2, we can. It's kind of boring because it's like you sign up for the API and then just use the tools. If people want to do that, I'm happy to do it. I think there's other stuff out there that's more exciting, but we can look at it. We'll just sort of see what we get into. But I'll say if there's something you just found that you're really excited by or saw someone talk about, like drop it in Slack and I can take a look at it. It's very likely that if it is cool, like we'll talk about it one of these weeks. But this is just some of the stuff that we will look at. Okay, before I jump into Colab and knowing that we're a little short on time, any questions about this? I know like right now it's all very abstract and kind of like, those of you who haven't dug into these tools, maybe you're like, oh, this is very confusing. Next week, I promise we'll like dig into it and actually apply some of these ideas to things. But any immediate questions that jump to mind? Okay, if you do have some over this week, drop them in Slack. I'm happy to answer them there. All right, so really quickly, I do want to talk about Colab. As of today, as I mentioned, I think we will be using Colab for most of this class. The reason we're going to use it is because the Auto 111 Web GUI can be run through Colab. So the Web GUI needs a GPU behind the scenes. And as of today, probably the most accessible, easily usable GPU is Colab. So we'll run these two together. But I might change my mind in a couple weeks about dropping Colab. If I can find better, cheaper alternatives for us, I will. But we'll sort of see how that goes. But I do want to talk about Colab because, again, Colab is sort of what everyone kind of leans toward today. That's changing a little bit in the Stable Diffusion community. But I would say for most machine learning, it's still like there's got to be a Colab notebook or it's not real, essentially. So for those of you unfamiliar with Colab, it's a product from Google. It basically runs Linux-based GPUs. One of the big challenges with GPUs that need like a GPU we need to do these machine learning models, it almost always needs to be a Linux version. And most of us don't have Linux computers sitting around at home. So it's pretty easy to access these GPUs without having to like install a bunch of code or like set up some crazy Windows server for us. That's kind of what the key for us is like we want a GPU that we can our Web GUI on top of to access and generate images from it. This basically allows you to generate images much, much faster. If we were to use our local CPU, it would probably take 20 minutes per image. With these GPUs, with Stable Diffusion, it's like 20 seconds, if that. It's like 5 seconds, 10 seconds. So a GPU really helps power our systems a lot more. If you do have a really high-powered Windows machine or a nice GPU, there are now tools to like get access to those things. And I'm happy to share those links with people for anyone interested. But for this course, I'm going to try to avoid like building up our own GPU because it's just kind of crazy. These use what's called notebooks. The most popular version is Jupyter. Notebooks are really kind of an interesting sort of like weird world of software development where basically they allow you to write code and comments all in one notebook and run things sequentially. It's actually a really good learning tool. I'm kind of surprised more people haven't adapted to it as like a learning opportunity or learning tool. But it does take a little bit of time to get used to because it looks very code heavy or like it looks like a big Google Doc you're running commands through. It's kind of a weird interface. Once you get used to it, I actually think it's pretty powerful and pretty helpful. But if you're new to Colab, it can take a little bit of time to get used to. Again, with this class, we're probably not going to really use that function so much as like getting a GPU set up and then spinning up a web GUI that we're going to access. But next week, we'll probably look at some tools that are still very Colab based. Free. It is still today free, but it's been very much hampered by new costs and other things. I'll get to that in a second. So what I like about it is text plus code. And it does include a bunch of dependencies. The biggest challenge with a lot of these tools is like to get them built on your own local machine, you need to spend a couple hours just building up all the right software and stuff to get it working. With Colab, it's just like you press play or press connect, and within 30 seconds, it's got everything installed you need it to be. That's really key because if I taught this class where I had to teach us how to install all the dependencies, that would be like 2 classes itself. So the key is it just helps us get up and running a little bit faster. The nice thing is it's a web URL. I can drop a web URL in our chat and you can open it and run it yourself. right? So there's no like, hey, go to Git. I don't have to teach Git in this class, which is wonderful. All these other things that could hamper software design doesn't really have to happen here, which is really nice. Downsides, there are time limits. They've gotten much worse. And there are GPU and CPU limits. Again, as I mentioned, Colab 3 months ago was a really awesome, well worth the cost tool. Today, I would say it's kind of worth the cost, but if you know what you're doing from like a server side of things, there's probably better alternatives out there. But for our class, it's probably still the best opportunity, like best sort of value for what it provides you. It is a Google product, so beware of that. So there are 3 flavors of Colab. The first is Colab, which is just called Colab. It's the free version. It is free. I don't even know how many GPU hours it gives you anymore. So long story short, it used to be you could run it for as long as you wanted to within these sessions. And then you would get a session, your session would die, you could restart it. And they would limit what GPUs you can get access to. Now they've moved to these things called GPU credits. And it's a very amorphous sort of like process where they say, oh, using this GPU for an hour is this many credits. But you're not really sure how that equates to like the cost or other things. It's very confusing. I've seen some people break it down, and basically it's kind of the cost of like, it's slightly cheaper than AWS, or like, sorry, not AWS, GCP, which is Google's cloud platform. The per hour is almost the same price as that. It's a little cheaper, but not by much, which means it's actually quite expensive. So a lot of the GPUs that we're going to run in this class are like, if you were to buy them on or rent them on GCP, it would be like 50 cents to 75 cents an hour. So you can kind of reverse engineer that and say $10 an hour, $10 a month for the Colab Pro is really only 24 hours of time using a slow GPU. After that, they make you pay per hour at pretty much the same rate that GCP is. Likewise, Pro Plus is $50 an hour. And it's the same sort of thing where like you get more credits. And those credits just last you a little bit longer, but only $50 worth really. And then they make you pay per hour for or you have to buy more credits in bulk.
Yeah, 50 a month, right?
Yeah. So there's the free version, which I think will probably give you a couple hours. There's Pro, which will give you like 20 hours a month. And there's Pro Plus, which will give you probably 100 hours a month. For this class, I think Pro is going to be fine for us. And if we need to pay a little extra per session or whatever, that's probably not the end of the world. But I will say, like, it used to be this was a great deal, and now it's not really. It's a fine deal. It's okay. The reason it's a fine deal is because we don't need to still spend hours building up all of our dependencies. If you were to rent a machine from GCP, you would still spend the first hour or two of that money building up a disk image or a Docker unit or whatever to actually like install the code. And then you don't really have Colab, or you don't have the notebooks sitting on top of it. You have to install the notebook software and install these other things. So for this class, it's actually still an okay deal because it does give us access to all these tools. But it's a little frustrating because they really changed the pricing model on this recently. So as I mentioned, like we'll use this for the first couple weeks. And if I decide it's not worth it, like I'll try to show us some other options. The problem is the price of a GPU is pretty much the price of a GPU. Every site has like basically the same price. There are some other tools where you can rent other people's GPUs, and like those are dramatically cheaper, but then they runs into all these other issues. I may actually show that like some tools like that toward the end of class. It's helpful for people to know about if you really want to run on a cheap budget. But it's kind of a challenge just because there's just a hourly price of what most GPUs cost. Yeah, so now there's this usage credits. There's also like the GPUs are either standard or premium. It's overall probably slightly cheaper, but not by much. Frustrating, but was kind of obvious what Google was doing. They were just trying to get everyone hooked on the product and then raise the price, classic sort of startup model. So I think there's still value in Colab. I think the idea that we can share URLs and that sort of thing still makes it really nice, but it is a little bit more frustrating and annoying compared to what it used to be. So we're at time. So what I'm going to do is I'm going to share the video that I've recorded previously for this class, just so people can see how Colab works. Who here hasn't used Colab before? No. Okay. If everyone's used it before, then like we'll probably be good enough to get through next week. So next week, we'll actually dig in. I'll just open up a Colab notebook and we'll walk through how to use it, how to set up the right GPU, that sort of thing. I'll use both a free version and a Colab Pro Plus version tomorrow or next week, just so people can see the differences between the two and they can sort of decide what's worth the cost for them. But I would say like the nice thing about Colab is you can always upgrade or downgrade. So like maybe for this class, you're like, let me just upgrade to Pro Plus just so I can like not worry about it. And then after class is over, you're like, let me downgrade back to either the free or the pro version. They do kind of make pricing a little bit flexible in that regard. So we'll dig into Colab more next week. Next week, we'll really just like look at a couple different examples of different text image models. And we'll sort of see the aesthetic that each of them have, just so we can get a sense of like the range that really is available to you because of these image generators. And we'll also look at steps and some other settings we can set up. And we'll look at that web GUI as well, because I think the web GUI will be sort of like maybe for the next couple of weeks, that'll be really what we focus on using. Cool. Any questions before we finish up for the day?
Would you say that the version that we're going to be working with has become one of the dominant versions, the 8.1.1 version? Or whatever?
Yeah, I think that's become sort of the one that I've seen most people use, because that developer, like, again, the developer is like always on top of stuff and always adding the newest, latest features. What I think is really cool about it is it has built-in image to image, built-in video capabilities. It's got like, it's like pretty comprehensive, and it's a GUI that's readable or like legible to most of us as normal humans, which is rare for the space tools. It's definitely the one that I think for, especially for this class, will be easiest to use. But yeah, if you find other ones you like, we can always dig in and play with other ones too.
Is there any difference between the releases of the versions of stability, whatever it's called?
Yeah.
Diffusion,
yes, we'll talk about this a little bit more next week as well, and maybe in future sessions too. So there is Stable Diffusion 1.3, which was the first one they released. Then they released 1.4, and then Runway released 1.5. And there's some controversy around that release. In general, each of them is slightly better, but the area where you see things improve is more in that realism area. So if you've ever seen some of Stable Diffusion, you know the hands always look really gnarled. 1.3 was really gnarled, 1.4 was less gnarled, and 1.5 is the least gnarled, but it's still pretty gnarled. So, you know, that's sort of the like where we're seeing improvements. Actually, maybe next week I'll grab, there's a draft of or there's a screenshot from one of the papers where they actually show the differences or like the improved scores of the what we call FID scores for each version. And like 1.3 to 1.4 is a big leap. 1.4 to 1.5 is super narrow in terms of its like improvement. But I'd also say like FID score is just one way of scoring these images. I've seen people say that 1.5 is actually better in many ways for realistic images, like portraits or that sort of thing.
Okay, great.
I have a question.
Yeah, please.
I'm wondering how you made your screen video piece. So I don't really quite get how you got to that. Are you able to do like a quick little sort of narrative summary of how that was made? Or maybe that's for next week, I'm not sure.
No, I mean, I'll give you sort of the high level idea of how it works. And then we'll talk, when we get to the video session, we'll talk about how video works. So a video is just a series of images, right? So 24 frames per second means for every second of video, there's 24 images. Basically what you do with Stable Diffusion is you just break it into all those individual frames, and you run a batch process over each image using the same text prompt. And really what that does, it just does this noising process per image, and then you stitch all back together into a video. And that's why it's flickery, right? That's why there's like no stability across it.
I mean, I kind of like that aspect of it actually, but that's because I like doing stop motion and stuff with individual images.
It has a very stop motion looking feel to it. Yes, exactly.
So you said that you were using clips or images from film where people are screaming.
Yep.
So how does that factor in?
So let me actually I can just pull up one of these. Let me
Okay.
just share my screen here real quick. So for this project, I had a friend of mine, I basically sent him a bunch of like clips from films, and he cut out 3,645 individual clips of like scary scenes or people screaming or whatever from these films. In the whole month that I've been doing this, I'll share this in Slack for people that are interested. The whole month has been literally me just like finding different ways to utilize these clips. So a lot of them are purely like, I'm sorting them by loudness, or I'm sorting them by male images versus female images, like those sort of things. So these just sort of look like, let me just grab one here. Like I know this one has some good scream images in it. So this is literally just like what these clips are. Go to flip this around. So that's what one of the clips looks like. I think one of the clips used in that piece is actually this one. Let me just see. So you'll see it's just an image of a woman looking scared or like, frightened. So we'll talk about this when we get into images and video, but you can actually feed in an image into these models. It adds a little bit of noise to it, and then it still does the diffusion process on top of it. So this is where I was mentioning like style transfer. This is kind of like back to style transfer in a way, but instead of using an image and a style image, using an image and a text prompt. And that's kind of what's interesting here is like, we can then start to dial in, like one of the things, if you were to watch that video, you'll see like, oh, when it's here, like you'll see that the image kind of understands the face, the hand needs to be under the chin, right? And when you look at like, Edvard Munch's screen, that's like perfect, right? It's like this. Other places it's trying to interpret the body and trying to style on top of it. And this is where steps come into play, right? If you have a very small amount of steps, you will get an image that looks very much like this with like a very light amount of style transfer on top of it. If you set the steps a little bit higher, you'll get the image completely restyled, but you might lose some of the form. And that's how you get that stop motion look, right? Because it's trying to interpret these images in a more loose way. And that's sort of the challenge with this stuff, is like dialing in that right amount of steps, because if it's too small, then you don't really get that style. If it's too big, then you don't really get the video sort of feeling like it's like captured underneath it. So that's kind of one of the challenges. And like, that's the thing we'll definitely talk about when we get to images and video, because dialing that in is so hard. And it's really hard, especially Stable Diffusion, because Stable Diffusion only has so many steps. So like the difference between 10 steps and 11 steps might be big because the steps are really large in Stable Diffusion.
Okay. Yeah, thanks. That helps me sort of understand a little bit better what was going on there.
Yeah, totally. Any other questions? Cool. If you do have other things, if you find cool videos or like other things people have posted and you're just like, how did they do this? Drop it in our Slack channel. I'm happy to like sort of do a little diagnosing and trying to figure out what's going on there. Cool. All right. Well, thank you for a great first week, everybody. Thanks for sticking with me 5 minutes after. Next week, we'll just dig into these models and start playing with them. So it'll be pretty exciting.
Thank you.
Cool.
Bye.
See everybody next week.
Thanks.
Bye.
Bye.